Right now, a named storm is crawling across the U.S. Gulf Coast, and it has already made landfall twice. Tropical Storm Bertha formed off Florida's coast just days ago, slammed into Louisiana, pulled back out over open water, and is now heading toward Texas for a second landfall. Storm surge has pushed water 2 to 4 feet above normal along hundreds of miles of coastline. Tornado warnings have gone out across the Gulf states, and forecasters say this storm might not be done yet. Today, we're breaking down exactly what Bertha has done so far, why it keeps weakening and strengthening in this unusual back-and-forth pattern, and what it means for the people still in its path along the Texas coast. No guessing, no dramatizing, just the facts, the science, and the real stakes. Drop a comment right now. Have you ever ridden out a tropical storm or hurricane? Tell me where you were and what it felt like. If you want to be the first to know every time something major happens with Earth's weather and geology, subscribe to the channel right now. It is completely free. The thumbs up also helps enormously. Let's go for 5,000 likes on this one so the algorithm actually shows it to the people who need to see it. Thank you. Now, let's get into it. How Bertha came together. Tropical storm. Bertha began as a disturbance in the Gulf of Mexico off Florida's west coast over the weekend of July 18th and 19th, 2026. It organized into a tropical depression and then strengthened into Tropical Storm Bertha, the second named storm of the 2026 Atlantic hurricane season, by Monday, July 20th. By Tuesday afternoon, Bertha was churning roughly 105 miles south-southeast of Mobile, Alabama, moving slowly northwest at about 6 miles per hour with maximum sustained winds of 60 miles per hour. From the start, forecasters described Bertha as a lopsided system, meaning the bulk of its heaviest rainfall and strongest winds sat well south and east of its actual center, mostly offshore. That detail mattered enormously for how the storm's impacts played out. The National Hurricane Center issued tropical storm warnings stretching from the Florida Panhandle, including Panama City and Pensacola, through Mobile, Alabama, Gulfport, Mississippi, and all the way to New Orleans, Louisiana. A storm surge of 1 to 4 feet above normally dry ground was forecast from the mouth of the Mississippi River to the Alabama-Florida border, particularly if that surge coincided with high tide. The first landfall and why it didn't get worse. Bertha made its first landfall along the Louisiana coast on Wednesday, July the 22nd, with maximum sustained winds that had already begun weakening from its Tuesday night peak. Forecasters at the time noted something important. Because the storm's most severe weather remained pushed to its south and east rather than concentrated at the center, the overall impact on inland communities stayed relatively limited compared to what a more symmetrically organized storm of the same wind speed might have produced. Beaches from the Florida Panhandle westward through Alabama, Mississippi, and Louisiana still saw dangerous conditions, including coastal flooding, rough surf, and a high risk of life-threatening rip currents that persisted for days. The Weather Channel's forecasters also flagged the possibility of isolated tornadoes spinning up along the northern Gulf Coast, a common hazard in the outer rain bands of tropical systems making landfall. Rainfall totals across the Gulf Coast generally ran in the range of 2 to 4 inches, with isolated pockets seeing as much as 8 inches, according to National Hurricane Center rainfall outlooks. Forecasters warned that flash flooding remained possible, especially in urban and low-lying areas, though major widespread flooding was not expected to be. The storm's primary threat, unlike the kind of catastrophic rainfall events we've covered on this channel before. The strange back-and-forth track. Here's where Bertha's story gets genuinely unusual. After making landfall in Louisiana, the storm didn't simply move inland and dissipate the way most tropical systems do once they lose access to warm ocean water. Bertha's circulation held together well enough that it pulled back offshore, re-emerging over the Gulf's warm waters before setting up for a second approach, this time toward the Texas coast. Meteorologists explained that this outcome depended heavily on how much of Bertha's core circulation survived its interaction with land. Since the storm's structure stayed intact rather than falling apart over Louisiana, it retained enough organization to reconsolidate over open water. By Thursday, July 23rd, Bertha was moving inland again, this time near the Texas-Louisiana border, with maximum sustained winds that had continued their gradual decline to around 45 miles per hour. The National Hurricane Center's forecast track showed Bertha's center tracking near or along the upper Texas coast before pushing further inland and gradually dissipating over the following day. Some computer forecast models had suggested Bertha could actually strengthen again briefly before this second landfall if it managed to consolidate further over open Gulf water, potentially producing wind gusts up to 60 miles per hour along the Texas coastline. Coastal Texas communities were advised to prepare for high surf, dangerous rip currents, and localized flash flooding as Bertha's outer rain bands pushed inland. Why storms? Like this weaken and strengthen unevenly. To understand why Bertha behaved this way, you need to understand what a tropical storm actually needs to survive and grow. Tropical cyclones are heat engines. They draw energy from warm ocean water, evaporating moisture that condenses and releases heat higher in the storm, which powers the whole rotating system. When a storm moves over land, that fuel source gets cut off almost immediately, and friction from the rougher land surface disrupts the storm's organized circulation. This is normally why hurricanes and tropical storms weaken quickly once they make landfall, and generally continue weakening as they move further inland. Bertha's situation was shaped by a specific combination of factors that meteorologists were watching closely throughout the event. AccuWeather's lead hurricane expert specifically noted that dry air and hostile wind shear across the Gulf were expected to be the biggest limiting factors on how much Bertha could strengthen at any point in its life cycle. Wind shear, the change in wind speed and direction at different altitudes, tends to tilt a storm's structure and disrupt its ability to organize a tight, symmetric core. That's part of why Bertha stayed a relatively weak, lopsided system throughout its track, rather than rapidly intensifying the way some Gulf storms have in the past when conditions align more favorably. At the same time, brief passages back over warm, open water gave the storm just enough opportunity to partially reorganize between its two landfalls, which is precisely why forecasters kept the door open for modest re-strengthening ahead of the Texas approach, even as the storm's overall trend remained one of gradual weakening. Bertha's place in a broader weather pattern. Bertha's slow, grinding track across the northern Gulf Coast happened alongside a broader stretch of active weather across the country. In the days surrounding Bertha's landfall, severe thunderstorm warnings hit parts of the Northeast with damaging winds and hail. Flash flood warnings were issued in the mid-Atlantic region, and a fire weather watch remained in effect across parts of the Pacific Northwest, a reminder that during peak summer months, the atmosphere is frequently generating multiple entirely unrelated hazard types across different regions of the same country simultaneously. Bertha itself, as the second-named storm of the 2026 Atlantic hurricane season, also fits into a season that forecasters have been watching for signs of how a developing El Niño pattern might suppress or reshape. Overall storm activity in the months ahead, since El Niño conditions tend to increase wind shear across the Atlantic basin in a way that can limit how many storms reach major hurricane strength. What coastal residents actually experienced. For residents across the northern Gulf Coast, Bertha's practical impact came down to a mix of manageable but genuinely hazardous conditions rather than catastrophic destruction. Tropical storm force winds in the 40 to 60 mile per hour range are strong enough to snap tree limbs, cause scattered power outages, and make being outdoors during the peak of the storm genuinely dangerous, particularly along exposed beaches and piers. The storm surge of 2 to 4 feet, especially where it aligned with high tide, was enough to push seawater into low-lying coastal roads and properties near the immediate shoreline. And the rip current risk, which persisted for days even after the storm's winds had weakened, represented one of the most serious ongoing dangers of the entire event, since rip currents can pull even strong swimmers out to sea well after a storm's most visible impacts have passed. What happens next? As Bertha continues its track through eastern Texas, the National Hurricane Center expects the storm to keep gradually weakening and dissipating within a day or so of its second landfall. Coastal communities along the middle and upper Texas shoreline are being advised to stay alert for high surf, rip, currents, and pockets of flash flooding from outer rain bands, even as the storm's official wind speeds continue declining. Meteorologists will continue monitoring the broader Atlantic basin for the season's next system, since Bertha's formation as only the second-named storm of the year keeps this hurricane season on a relatively typical pace so far, though forecasters caution that the most active stretch of the Atlantic season historically still lies ahead in August and September. Final thought, Bertha will likely be remembered less for its wind speed, which never came close to hurricane strength, and more for its stubborn, unusual track. A storm that refused to simply dissipate after its first landfall the way most weakening tropical systems do. That behavior is a genuine reminder that a storm's category or peak wind speed doesn't always capture the full picture of its risk. A weak but disorganized, slow-moving system that lingers along a coastline for days can produce a longer, more drawn-out hazard through surf, surge, and rip currents than a stronger, but faster-moving storm that clears an area in hours. As hurricane season heads into its historically most active months, Bertha is a useful case study in just how unpredictable even a modest tropical storm's exact path and behavior can be. We will keep tracking this story and every other major seismic, volcanic, and extreme weather event happening around the world. Right now, subscribe so you don't miss the next update, and leave that comment below. Have you ever ridden out a tropical storm or hurricane? Tell me where and what it felt like. 5,000 likes on this video. Let's go. See you in the next one.